I don't know, that might work too for some. A bit of vocabulary before we move on to the next section. This is still 4.1. Measurement of angles, you can measure it in one of two ways, either degrees or radians. Degrees would go from 0 degrees to 360 degrees. Radians 0 to pi. You go for the second revolution, then you start at 360. Simply add 360, you go all the way up to 720, and so on. Same here, you would start at 2 pi, add 2 pi, you get to 4 pi. And last time I mentioned how you would convert degrees to radians. How do we do it? Suppose you have a degree value, what would it be? Radians times pi. You take the degree value, multiply it by pi divided by 180 degrees, you will get the corresponding radians measure. And the other way, if you want to convert radians to degrees, you would simply take whatever radian measure you have and multiply it by 180, divide by pi. You'll get the corresponding degree. Naturally, degrees angle measured in radians would have decimal values. For instance, you could have 37.29 radians or 1.72 radians. In engineering and most sciences, such as physics, usually the measurement is in terms of radians, but in physics they use angles in degrees, and if you start observing stuff in 3D space, say planet, whatnot, it's in degrees. Suppose I have a radian measure. And I want to convert that to degrees. You can tell me how. Naturally, you must get a large number for that value in terms of degrees, because 1 radian is equal to 'Did I not mention this last time? One radian would be pi. In total, you would have 2 times pi. Or you can just use it in that formula. If you plug in 1 here, you would get 180. Oh, my bad. Oh yeah, and pi radians would be equal to 180 degrees. a full revolution is 2 pi. And 2 pi is about, well, it's not about, it's 6.28. Yes, 2 times pi, 6.28. So that would be the corresponding value for 2 times pi. Well, 2 times pi is 380, and it's only about 6.28, right? Now that is going to result in a very large number when it gets over here. So I have 42.67 times 180 divided by pi. What do you get? 2,444.89. Okay. So pretty much a huge value. You did not do one rotation. It sort of went round and round and round. And if I want to know the number of revolutions, how would you calculate it? Divide by 360 degrees, and you will know the number of revolutions. I'm going to spell it in words because units behave similarly to, or similar to, a variable, just like how you can cancel the numerator variable with the denominator variable. You can do the same thing with units. Quite important if you get into physics. 2,444.81 degrees divided by 360. Those two would go out. How many do you have? Seven. 6.7, approximately 6.71. So you completed 6 revolutions and then 3/4 of one. So that's how you find the number of revolutions. Great. One more thing that we've got to know about degrees. Let's consider let's have 2.1 radians and convert that to degrees. Even before you start, is the answer going to be between 0 and 360 degrees? No? Why not? Because we have 2.1 radians. So 2 pi was equal to 360. Yes. Yeah. So if I convert to degrees, we'll have 2.1 times 180 degrees divided by pi. And what do we get? $120.32. What are you making it? Is that number bigger than 360 degrees? No, so what, Riley, it's going to be bigger.
I messed up as a pi.
Because it's a pi. It messed up because of pi. Do keep in mind, 2.1 is not 360 degrees. 2 pi is 360. If this number were to be, say, 7.12, sure, it'll be bigger than 360. Not the case. I have 120.32 degrees. When it comes to decimal values, we don't specify it in terms of decimal values as far as degrees are concerned. So the breakdown is degrees, minutes, and seconds. Any thoughts as to why we call it minutes and seconds? So if you take a regular clock, 360 degrees, start to finish. So how do we measure clock? Well, you have the short arm, you have the long arm, and it goes around, and then it lands in certain minutes and seconds. And how many minutes make an entire hour? 60. So in our problem, we have 120 degrees. 0.32 will give us the minutes, right? 0.32 multiplied by 60, what do you get? Huh? 19.2 minutes, whatever that is remaining. So 120, I split it as 120 degrees plus 0.2 degrees. I'm converting that part to minutes. How many minutes did I get? 19.2 minutes is denoted by 1 positive. Now I don't want that to be an integer. Excuse me, a decimal. I want it to be an integer. So if I count for 19 minutes, what am I left with? Easy question. Second, what amount? What amount? If I count for 19, what am I not counting for? 0.2, right? So I'm going to keep 19 minutes. Good. 0.2 times 60. My bad. 12. Good. And 12 would be seconds. So double count of 2 first. So instead of writing it as 100.32 degrees, we write it as 120 degrees, 19 minutes, 12 seconds. Good. Now I want to go in reverse. How would I do that? Want to go back to where I started. There are multiplied, yes, by 60, and then I multiplied again by 60. Now, what should you do? Divide, right? So, 12 seconds, you've got to multiply by what amount? If you multiply by 60, what would you get? How many seconds? calculating. 12 seconds. Times 60. 12 seconds, if you multiply by 60, you get 720, which is seconds. If you divide by 60, 12 over 60, what do you get? 1/5. 1/5 is 0.2. Good. And take the minutes part. What would you divide by? 60. So 19 minutes divided by 60, what would you get? Definitely 0.3 centimeters. 0.2. 0.31. Right. If you add those together, oh, wait a minute. I have to divide by 3,600 number of seconds. My bad. So what do you get? So it should be 0.1 over 300.
Yeah.
0.33. My bad. 1 over 3,600. You have 3,600 in 60 minutes. 1 hour. Bad. So if you add those two together, you would end up getting 0.319. Yes, 0.319 approximately. 0.32. That makes sense. So you can go back and forth, but when people use a particular notation, you don't look at the decimal. You don't treat it as a decimal, rather you put it in terms of minutes and seconds. Good? Okay. What is the shape of a traditional clock? I'm not talking about your iWatch, what's a crappy word. I'm talking about the traditional clock. A circle. Not bad. It's a poorly drawn circle, but it will illustrate points. Center is the origin. When I was talking about the clock, I mentioned a short arm and a long arm. So you have two things to distinguish as to how you measure the angle. In math, where you start is called the initial side, and where you end would be the terminal side. Because I sort out the circle right on the edge of the circle, but one person extend it and put arrows indicating that it's going in that direction. No matter how far this goes, the angle would always be the same. Do you agree? A line with an arrows keeps on going. It's called going back to what middle school. So red whatever angle you sweep. Will correspond to the angular measure. Angle. The angle is typically denoted by the letter, Greek letter, theta. The distance from here to there is called the radius. I'll use the letter R. If the ray parts, I drew the ray part to indicate that no matter how far the lines go, the angle would be the same. Checking the ray side. Here we have this x-axis. The distance from here to there is called the arc length, or length of the arc. The way that arc length is a portion of the circumference of the circle. Yes, that entire length, imagine you have a circle. If you open it up, make it a line, the length of that line would be equal to the circumference of the circle, which is 2 pi r. Agreed. So 2 pi r, regardless of the radius, would be the length. So one full revolution is how many radians? 2 pi. Okay. This is the formula for the angle. Theta is simply the length of the arc divided by the radius of the circle. But if you went one full revolution, let's say somehow you are standing right here and center to that point would be, should we go with the metric system? We should. Better. Let's say that is r centimeters. Good. Do we know what metric system is? It would be a shame if you don't know what a metric system is. Okay, good. So r centimeters, and if you start here and you walked and you ended there, what is the distance that you walked equal to? Easy question, we just addressed that. Pi squared, that is the area of the circle. Think of the distance. You start here, you've completed, you came over there, right? What is the distance that you covered? 2 pi r, the circumference. So, going back, so you started on the x-axis, you completed one revolution, back to where you started. I would like to know the angle. So theta would be the total length that you traveled, 2 pi r, divided by the radius r. What is the result? 2 pi. So the units will get cancelled because If the radius is in centimeters, the circumference will be in centimeters. Centimeters divided by centimeters, those two go away. The r's will get cancelled. So we have 2 pi radians. Good. Let's say you only traveled a quarter of the circumference. Okay, the total length is 2 pi r, and you only travel quarter of the distance. So what is the corresponding degree in degrees, or the corresponding angle in degrees? Do you follow? You travel quarter of the entire circumference. I would like to know the answer of the angle in degrees. 90 degrees. How did you get that here? Quarter of 360. Well, in terms of this, how would you get that? Okay. So if you use this definition, the total circumference is 2 pi r. Yes, I'm traveling a quarter of the total circumference. In other words, the length of the arc is a quarter of the total circumference, which is 2 pi r. Divided by the radius, which is r. What would happen to the 2 r's? What would happen to the 4 and the 2? Easy question. Two. So theta would be pi over 2 radians. They are pretty rad. In terms of degrees, if we want to convert that, what would you do? Multiply it by from earlier. 180 divided by 5, which would be 90 degrees. Good. Yes. This position that we use right here is called the standard position. It is called the standard position because we always consider that we're consider the origin, start of the origin, and our reference position is the x-axis, and we want to know how far we go from the x-axis, which is why we call this the standard position. Well, what could be a non-standard position? Well, one case would be where I move the center away from the origin. Good. So I can move it up here, or I can move it down there, and then draw a circle. That's case number 1. Case number 2, which is more complicated, I could start, say, somewhere here, which is clearly not the origin, and make that my initial site, and make that my terminal site, right? So you're pretty much messing things up. You're changing the reference axis. So things would get confusing, which is why we stick to this. Okay. I'll ask you to do a problem in a bit, but before we go to that, 3 types of angles. We'll know what they are. What? Okay.
Up to Q and rec.
Up to a cube. we'll start with acute. What is an acute angle? Less than 90 degrees, which means negative 120 is less than 90. And greater than 0. An acute angle is between 0 degrees and 90 degrees. Mind you, I'm not including 0 or 90. Good. What is an obtuse angle? Is it fair to say anything that is non-acute is obtuse? Not really, right? What? Can you, Salafia, can you hear him?
No,
No.
because there's right angles.
Why is Hanny? It's just louder.
Because there's right angles.
Because there's a thing called right angles. Right? So obtuse doesn't necessarily mean anything that is non-acute. Typically 90 degrees all the way up to, you tell me, is it 180 or is it 360? Yes, 360. 360 degrees. We'll make it obtuse. Right angle is exactly 90 degrees. Good. So if you want to sketch it, a standard case, in standard position, assuming standard position, that is an acute angle. Yes? Assuming the standard position, that is an obtuse angle. That is a right angle. Good. Right. What are the terminal angles? Or terminal is where something ends, correct? So what is a terminal angle? Can I call 0 degrees a terminal angle? Yes. And what would the next terminal angle be? 360, where you end. Okay. If the terminal site simply lies on the x or y axis, so if the angle falls, or not the angle, if the terminal side falls exactly on the x or y axis, then we call it the quadrantal angle. How many do we have? In the standard position, considering one revolution, how many can you think of? It's 5. If you pick the terminal side could fall exactly on top of the initial side, which would make the angle to be 0 degrees. Agreed. Terminal side could go to 90 degrees, fall on the y-axis. So 90 degrees would be the other quadrantal angle. Terminal side could fall on the x-axis, negative sign. So that would be another quadrantal angle. And the last one, it falls right over there. Good. So there are 4 of them So 0 degrees, 90, 180, 360. All quadrants around this. Good. Now, in terms of direction, did I go clockwise or anti-clockwise or counterclockwise in measuring the angle? I moved counterclockwise. Do we know as to why we call it counterclockwise? Opposite way of the clock, because the clock goes clockwise. Silly. Instead of going this way, standard position, origin as the center, going in counterclockwise direction. If I wanted to go in clockwise direction, the angles that I form will not be positive, right?
The 360 is supposed to be 270, right?
I skipped, my bad. So 270 degrees, then 360. So 0, 90, 180, 270, back to 360. But there is another name for it, I won't get to it yet. So we'll keep these four, but 360 degrees is also important. But there is another name, we'll get to that. So instead of going counterclockwise, if I stick to the clock and go in clockwise direction, whatever angle that you measure would be negative. So these are positive angles because you are adding to 0. Yes. If I go in the opposite direction, what am I doing? I'm subtracting from 0. Yes. So instead of having, say, that's probably about close to 40 something, if I drew the terminal side here, that angle below the axis going this way would be a negative angle. Good. The angle that I have, theta, is the positive angle. So theta, positive angle. I guess I can call this theta prime. Negative angle. Used in some cases, I'm all about positivity. Let's say I don't like the negative angle that I have. Can I erase this? Yes. Let's say I don't like negative angles. So x-axis, standard position, that's the origin, forming an angle below the axis. And I'll give you theta prime to be, has to be negative angle, negative 300, sorry, negative 30 degrees. Good, start simple, yes.
So that would be the same.
Come again,
Would that be equal to positive 350?
350, what 350? 330. So if I don't like, negativity, I can go in the positive direction. So if you move in counterclockwise direction, that is the angle you would form, correct? You're not completing a full revolution, rather you're going up to 330 degrees and you stop. So the corresponding positive angle, theta would be 330 degrees. But in general, positive angle theta in degrees or radians would be equal to, how did we find this? What do you do?
360 minus theta prime.
360 degrees. Riley, louder, can't hear you.
360 minus theta prime.
360 minus theta prime. Is it right there? Why can't it?
So already negative.
It's already a negative, right? By my definition, theta prime is negative, so it should be plus. Of course, you can't change the definition entirely. Are we clear? We have another set of another angle, which is called a straight angle. Any thoughts as to what a straight angle is? We know what a right angle is. 180 degrees. A straight angle is going to fall flat relatively to the initial side. So now, earlier I mentioned that you could have any angle all the way up to 360 being obtuse. But now that I've mentioned straight angle and negative angles, let's think about the definition for an obtuse angle. Good. So let's say I form an obtuse angle. Yes. What is the corresponding negative angle? That would it form? Or I guess I'll put a number to it. Let's say it is 130. 42. How about that? Theta is 142. I would like to know the corresponding negative angle. Huh?
Negative 180.
Negative 180. Whatever that's left.
164.
64. What kind of math are you guys doing? 218.
Yeah. 188.
Huh?
Oh, I thought we were just yelling out
No.
random numbers.
What is the negative angle?
Negative
Negative
2.
Negative 218. How did you get that? Huh?
Subtract it from 360.
Subtract it from 360. No. This angle clearly is not acute. So when you form an obtuse angle, you pretty much are connecting it to another negative angle that is not acute. So instead of going all the way from 0 to 90 and above, all the way up to 360 as obtuse, we will just stop from 0 up to 180 degrees. So sure, I can call it going all the way up to 90 degrees, but since we have defined a straight angle, and we simply look from 0 to 180, if you go up to 90, you would have a cube. 90 to 180 sufficient enough to call it as obtuse. Good. So formally, obtuse angles 90 to 180. So just to recap, IQ 0, 90, obtuse 90 to 180. I'm changing that definition because all I have to do is look at one half. The other story I can get it from the remaining. Good, you see why I'm making that change. Straight angle. 180 degrees. That's what people commonly use. Could I call 0 degrees as a straight angle too? In the standard position. Still straight, right? So, yeah, sure, why not? If you go in the other direction, 0 would become 180, correct? So, sure, 0 degrees is a straight angle. Let's say I move away from the standard position, and let's say you tilt your head sideways. Good, with me? And my y-axis is my reference axis, x. Good. If that is my x, and I am going to go clockwise, so on my initial side would be right here, and my terminal side would fall on that axis. So in that scenario, I'm not in a standard position. What is the straight angle in that case? Don't keep it tilted too long, you get head. Do you follow my question? This is the standard position. Let's standard position uses x-axis over here. I want you to assume a non-standard position. Well, this is my x-axis, arbitrarily speaking. And your initial side is here. Your terminal side is going to fall on the axis after a 180-degree rotation, or half revolution. So what would be a straight angle in that case?
The y-axis,
Huh?
the whole y-axis.
The y-axis, but what angle relative to this one? 90, right? So if you tilt your head out, if you tilt it sideways, and if that is your reference axis, initial side, whatever terminal side, wherever terminal side falls, would correspond to 90 degrees in the standard position. With me? So let's not get too confused looking at non-standard positions. In most cases, we simply stick with the standard position. Now, is it fair to say, whatever equation that I wrote earlier, that the positive angle theta would simply be 360 degrees plus theta prime, which is my negative angle. If that is the case, can I simply write whatever theta that I have here in radians would be equal to 2 pi plus theta prime in radians? Do you agree? Would that statement be true? Yes, no. Yes. Think about it this way. If I simply multiply both sides by pi over 180, I'm taking that entire equation that is in terms of degrees, converting to radians, as long as you do it on both sides. If you go on both to multiply by pi over 180, you're simply getting the equation in radians. So it is a matter of choice. Either you can find this in radians then convert it to degrees, or find it in degrees directly. It is totally a matter of choice. I'm going to first convert the negative angle that I have to a positive angle. So 2 pi minus 3 pi over 7, which would be 14 pi minus 3 pi divided by 7, 11 pi divided by 7. Yes? So when it comes, it is a matter of choice. Should you use that or that? You pick. I'm going with radians because they are round. Also, where does the word radian come from? Why do we keep calling it radians? Any thoughts as to why we call it radians?
Radius.
It has everything to do with the radius of the circle, hence radius. And last step, I'm going to convert it to degrees, so 3 pi 11 pi divided by 7 times 180 degrees divided by pi. What do we get?
130.
630. Divided by 7.
I did a different one, but
That's okay.
it should be 77.
77.77.
That's what I want.
Well, I just did it negative 3 pi over 7 times 180 over
Yeah.
pi, and then I converted it out.
That's fine.
So
So
it's just
negative 3 pi over 7 times 1.
Oh, you're, okay, and 3 to 1.
Yeah, so 282.857. But you can do it the other way also. In other words, you can convert that to degrees first, then plug that in there, and then you can get to this. It's entirely up to you. I'm using it this way. Well, that gives you the answer in degrees, but I want to not specify in terms of decimals. So 282 degrees. First line, you multiply by 60, 0.857 times 60, what do you get?
51.6. Not exact, but I just
Oh, we
rounded
want
to
31.2 decimal places.
42.
42, and that would be the minutes time. So 51 minutes. Whatever that's left behind, what should you do? Divide by 60 again, so 0.42 times 60, you will get how many? 25.2. I'll call it 25. So eventually you have to leave a tiny bit behind. So the final answer here is 282 degrees, 51 minutes, 25 seconds. When in doubt, you can always draw, yes?
How strict is it when it comes to the seconds part? Because I rounded, so I got 36. And I only rounded one spot, but since it's in seconds.
When you multiply 0.42 by 60, you get 36.
I didn't get 142. I rounded it.
Well, because like you gave a third decimal, and if you round to like 86,
Yeah.
your seconds are off.
Oh, I see. So this is what you should do. Go to look up. Remember this checking program. Go 1 second. Anytime you round at the very last step. So each time you round, you are introducing error. The key idea in general would be round at the very last step. So retain, say, 3 or 4 decimals and keep going at the very last step, round to 2 decimals. Each time you truncate, you would introduce error. And there are cases where having too many digits could also result in error. My lab usually will tell you how many decimals. Very
Wait, so my question, what you kind of just explained, it, so you don't round this up very end. So you just do all of it with the 0.857.
Yeah, so you just take the entire 0.857 and then multiply. And I'm going with 0.857 because that's what I got. Now, before we run away, you can always verify your concepts. But it doesn't count for partition again. I have negative 3 pi over 7, right? 1/4 level is 2 pi. And over here, I would have how much? 3 pi over 2, 0 pi over 2, pi, 3 pi over 2. Looking at the negative angle, in the negative angle side, this would be negative pi over 2. Agreed? Negative 3 pi over 7 is less than negative pi over 2. Do you agree? Yes? What is 3 over 7? 0.1. Use your calculator, 0.4128 or is it 428? Okay. So negative 0.428. And that would be negative 3 pi over 7. Yes? So whatever positive angle that you get, so this is the negative angle, whatever angle that you get must be that. And that number is bigger than 270 degrees. So whatever answer that you have, better be bigger than 270. Is 282 bigger than 270? Yes. Okay.